Hey class, how's it going? I hope you're having a good one. Let's talk a little bit about lists, seeing as how we discussed it in class a little bit, but I want you to have this to refer to reference if necessary, and then we'll talk a little bit about the assignment in which you're going to be working. So I'm going to define the main function as always, and as part of the requirement for the principles exam, the AP Computer Science principles. When you create your program, you have to include a function. So we've looked at functions with parameters and also lists. And so in this tutorial, we're going to start looking at what a list is and why they could be beneficial. Now, in class, I talked about having a list of students, like student 1 being the first student. If I remember correctly, that was Trevor. And then student 2 being the next student. Oh, excuse me. I'll just make these up. Exactly, student 3. And so what you notice here is that I'm using 3 separate variables, student 1, student 2, and student 3, to hold names of my students. And you can see how if you have 100 students, or 150, if I'm considering all my classes, then having 150 students doing this that way would require that I write a minimum of 150 lines of code, and more importantly, there would be 150 different variables. And so when we are trying to store large amounts of data, which actually is probably the case for almost any programming application, when you're trying to store a lot of data, you don't, and that data somehow relates to one another. In case these are all names, in this case, they're all names of students, then it's convenient to make a list, or what we refer to as an array. An array is a list. And I'll call this an array of strings. String, again, is a data type that has something within double quotes. And so here I'm going to make the student array. And how do I make sure it's an array? Well, I put these elements, we call them elements, that are of data type string. I place them within square brackets and I separate them by a comma. Notice that I could write as many names here as I want. Right now there are 3. And in the class we talked about printing these. So we said that if we want to print the first name in my list, in my array of students, we use the index notation where we say print and we write the name of the array or the list. And within the square brackets, we write the index value, meaning where is this element located? And indexing starts at 0. So for every array, the first element is the 0th element, and then the first element, and then the second element. So however many elements you have, in this case I have 3. There are 3. The last element its index value will be 1 less than that. So in this case, Alex is the second element. 0th, first, second. And so when I come in here and I want to print just the first, and I say first, but let me clarify. When I want to print Trevor is at index location 0. And so if I print this, now it's going to prompt me to save this, which I will. Under documents, and then we'll go to Python tutorials, and we are looking at lists now, or arrays. And I'll call this just students. So notice it prints Trevor. If I want to print Oscar, well, I would just take this print statement, I would copy it, and then I would print Oscar by putting a 1 here. So Oscar is the first index, Trevor is the 0th, Alex will be the second. So I could once again take this and then put a 2. And so the way you read this right here is not students square bracket 0. You read this as students of 0, which I'll write here. And then print students of 1. That's how we read it. And you can see how students of 2 would be the last one. Now if I run, it's going to print all of them. And then we once again said, well, okay, that's good, but what if you have 100 elements? You have 100 names. You don't want to do 100 print statements. And that's where we said, okay, well, we can use a loop. We can use a while loop where we initialize I to be the index, the first index. That would be 0 is the first index right here. And then we can say that while I is less than, well, what's the last number I want here is a 2. So while I is less than 3, or you could say less than or equal to 2, we want to print the student at location I. So I would be 0. So that's students of 0. And after we print the student at that location, we want to increment I by 1. And that means that the next student, when I print students of 0, I'm going to increase I to 1. I'm going to loop back, check the condition. 1 is still less than or equal to 2. So I'm going to print students of 1, add 1 to I. So I is 2 now. Loop to line 13, check if 2 is less than or equal to 2. It's equal to it. So I'm going to finally print students of 2. And so this will have the same effect as doing this right here. Notice that I print the list twice. Now let me take this one step further and do just a print here where I'm going to print just some asterisks so that I can see clearly where one list begins and the other one ends. So this is from the first 3 of lines 7 through 9, these. And these are from lines, this is from the while loop at line 17 that is repeating. Now, why am I emphasizing that point? That's because if I add here, I add another student, maybe a couple more, then right here, this implementation will only still print the first 3 students, just those 3. Whereas the while loop, if I make one change, which is to change this to 0, 1, 2, 3, 4. So if I change this to a 4, now the loop is going to loop 5 times. So I will be 0, 1, 2, 3, and 4. And you can see how my code now is reactive. It is reacting to the change in the array, in the students array. So notice how it does indeed print this. Now, I did have to change this to a 4. How do I avoid that? Well, I use the length function. The length function, if I give it an array or a list, it tells me how many elements there are in there. So the length of students, len is short for length. Students is a list, an array, and it tells me how many elements there are. There's 5. 1, 2, 3, 4, 5. And so I would be less than or equal to 5. That's not good now because we don't want I to be 5. I will be 0, 1, 2, 3, and 4. So I know this, the length of students tells me how many elements there are. There's 5 elements. So if I'm going to use this implementation, I need to get rid of the equals. And now this code is, it automatically accounts for any changes in my list. So whereas right here, I would have to add an additional 2 print statements, the loop here takes care of any additional students. Notice that if I run this, Clarissa prints here. I didn't have to come in here and change this. All I had to do was add a student. And notice Luis shows up. So this is what a list looks like. We actually call these arrays. The AP documentation calls it a list, but we refer to these as arrays. We can also see how a for loop can be used here. The implementation would be even easier. We would say that for each name in students, and we remember that in a for loop, this variable is just a variable that we make up right here on the spot. So I could call it X if I wanted to. I could call it anything. What is interesting here is that name is the variable is going to be everything in students. Now, we have these elements in students. So name is going to be every one of these values. It's going to be Trevor, Oscar, Alex, Emiliano, all of them. Obviously, it's not going to be all of them at once. We're looping. So if I do here print name, name will be the first element in students. That would be Trevor. So we would print Trevor. And then name would be the second element in students, Oscar. So it would print. And we're looping and looping and looping. So these two loops do the exact same thing. I got rid of it, but let me just do another print statement in between them. Or I just have these asterisks just to basically be able to show exactly where one list ends and the other one begins. So notice this is being printed from the while loop in line 12, whereas this list is being printed from the for loop on line 19, where we're looping, okay? So two different implementations. When should you use one and when should you use the other? It just depends. There are times when this index variable I is convenient to use in different ways, and so maybe the while loop might be better. There are times when this might be better. We can also, one last thing here before we talk about the assignment, we can also just say that for every I, recall I, where it's different than this I. Actually, let me just give it another name, X. For X in, and we can use the range function. Remember that the range function gives you a range of numbers. If I only give one argument to the range function, so let's suppose I give it the number 5, then it's going to basically produce a range of numbers starting at 0 all the way up to 4. So it won't quite get to 5. So X will be 0, 1, 2, 3, and 4. We can print students from the list, the element at location X. And so understand that X will equal 0, start at 0, 1, 2, 3, and 4. Because when I use the range function, that's what it creates. It creates basically a range of numbers starting at 0 all the way up to one number less than the argument. So one less than 5, which would be 4. So that would print 0, 1, 2, 3, 4. It would print up to Nicolas. It wouldn't print Clarissa or Luis. Notice how it does, just print that. Now, again, we're hard coding the 5. So if I add a student here, I would have to come and change this. And so let's not do that. Let's take this same implementation. Notice that there are a total of 3, 6, there are 7 elements right now, 7 names. So this is the number 7. So I, the last value of I that is still less than 7 is 6. And students of 6 would be Luis. And so I can take this and just put this within the range function. I'm going to copy it. And I'm going to, instead of putting 5 here, I'm going to put the length of students, which is 7. And now my range of numbers are going to be from 0 all the way up to 1 less than 7, which is 6. And so we'll have 0 through 6. We'll print the students from starting at 0 all the way up to students of 6, which happens to be Luis. And so just, I want you to, again, notice two different implementations here with the loops. The while loop works this way, where we actually have to increment I within the loop. The for loop can work multiple ways. We can guess X as the value of the index using the range function, and print students of X, where X is going to be 0, 1, 2, 3, and 4, all the way up to 6, or the previous implementation where I had for every name in students, where name, the variable, takes the value of the elements. So I'm just showing you, I guess, multiple ways of doing the same thing. Notice the key difference here. X here is a number, and that is in the range of 0 to 7. Remember, this is 7. So X will be these numbers, 0, 1, 2, 3, 5, 4, 5, and 6. Whereas here, name is everything in students. So name will not be a number. Rather, it will be whatever you have in the list. So the first value of name is going to be Trevor. All right, here. Name will equal Trevor, and then it will equal Oscar, and then it will equal Alex, and etc. And so why is that different? That's because now when I print, I don't, oh, I'm forgetting the colon. Now when I print, I can just print a name because name has taken the value of the elements. Whereas over here, I need to actually still use what we call index notation. We need to refer to the list and refer to the index that we want to print. So this is kind of like our first look at indexing and lists. What I want you to work on, just bear here with me for a minute. Okay, so what I want you to do is I want you to write a function. As a matter of fact, just write within the main method. We're going to do the following. I want you to create an array called temps h. That's short for temps high, and temps l. Now you're going to go to just weather.com, and we're going to look at the 10-day forecast for our city, for Imperial. And I want you to get, and you can start with Monday. I know that would be this right here, Monday. I want you to get the high, and I want you to get the low. And I want you to populate your arrays with these temperatures. You can make it a week's worth of temperatures. So if I started here with Monday at 85, I would go down all the way to Sunday, which is 74. And so I would put all these values in the highs, and then all these values, 51, 53, 52, 51, in the lows. So that's the first thing you're going to do. You're going to populate the two arrays. That's what we call it. We're going to populate. So for example, right here, the first value for the temperature would be 85. That corresponds to the high for Monday, and then you would write the rest, and then the last one for Sunday was 74. So on Sunday, it's going to be cooler than today. And obviously, I'm missing temperatures. You're going to populate them, and then do the same for the lows. So today's low is 51. On Sunday, the low is going to be, I would think, less, 44. So I'll put here 44. Now, again, you need a 7. Now, when you're done, when you do this, then I want you to prompt the user for a day that they would like to know the temperature for. So like something like when we prompt the user, we need to recall that we need to use the input function. What day of the week would you like the high and the low? I mean, the question itself right now is not worded um, maybe the best way that it can be worded, but you're asking what day of the week would you like the high and low, meaning the high temperature and the low temperature. I'll put your temperature. And all you need to do here, so the implementation is not going to require any looping. You're just going to have to, based on what the user enters, you're going to have to um, access each of the two arrays and retrieve the temperature for that day. Now, there's more than one way you can do this. If you like, you could use, you could ask for the user. As a matter of fact, never mind. I'm going to tell you exactly how I want you to do it. It's going to be part of the description within the the assignment. But I've kind of gotten you started. What I want you to practice is indexing. So understand that this is at location 0. So is this. This is at the moment is at location 1 and location 1. And that's what I want us to get out of this simple assignment.